Let's look at a new term, cylinder. So this cylinder is has a broader meaning. Doesn't necessarily mean a circular three-dimensional shape. It's not a pipe. It doesn't have to be a pipe shape. So let's look at its definition. First of all, we have a curve C. So therefore, we have a curve C on some certain plane. So let's, for simplicity purpose, I'm gonna say this is my y, this is my z, so it's on my yz plane. And another line L, so this L is in this direction. Doesn't have to be parallel to x, it can be any direction. A cylinder is the surface consisting all lines parallel to L that pass through C. So basically I can draw, say I'm gonna, through point C, I'm gonna draw a line that's parallel to L. Through this one, so through this one, I'm gonna draw that one, and so on and so forth. Okay, so basically so this is parallel to L, this is parallel to L, so these are all lines parallel to L. So eventually this is the surface, so this will be the surface that has the curve C and parallel to L. So therefore this is actually called a cylinder. So that's what the definition says. Now how do we identify which axis to which a cylinder in R3 is parallel? So let's try to recall that in R2, for instance, in R2, if you look at this equation, x equals 2, and you know this guy is actually parallel to this particular line, is actually parallel to y-axis, right? Why? Because there's no y, missing y, basically missing y. You know it's going to be parallel to y. Because for any y values, x is always equal to 2. Similarly, when you see y equals 3, you know this is a horizontal line. It is parallel to x-axis in R2. Why? Because the missing x. So similarly, in R3, how can you identify which axis the cylinder is parallel to? For instance, if you have 2x squared plus y squared equals 4, you know this missing z, right? Missing z, and that means z can be any value, and then you still have the same curve. So therefore you know this is a cylinder that's parallel to z-axis. If you have equation like this, then because you know it's missing y, you know this cylinder should be parallel to y-axis. So this is how you can identify which axis the cylinder is parallel to. A new term here is a trace. So a trace of a surface is the set of points at which the surface intersects a plane that is parallel to one of the coordinate planes. And the trace in the coordinate planes are called the xy trace, xz trace, and the yz trace. Now, these two are vertical traces because xz and yz, they are vertical planes, so vertical traces. And the xy trace is the horizontal one. Let's look at the how to graph the following. So in the first one, we do notice that the z is missing, right? Therefore, you do know this cylinder must be parallel to z-axis. So first of all, make sure that that's clear. Now, it will be nice to look at the trace. So when z is 0, so I'm gonna say step number 1, when z is 0, you're actually looking at its projection on xy plane. All the trace of xy plane, so which is xy trace. Now why this is the xy trace? Read the definition again. So that's the in which the surface intersects a plane. In this case, the plane is z equals 0. And then when z equals 0, this is the equation on the plane, right? So therefore, it is xy trace. Now it is a ellipse, because you can see that this can be written as x squared over 9 plus y squared over 4 equals 1. And you can see that this is an ellipse. And then if we draw that in the xyz plane, here the major axis is 3, the minor axis is 2. So this is what it is. This is 3, this is 2, this is -3, -2 here. Okay, so now to draw a credible graph, you also want to draw other traces. Say draw another trace for now, another trace. And then this is pretty, you have a lot of freedom to do whatever the trace that you want. So I'm going to say at z equals 3, so which means when z is 3, suppose this is 3, and then you do another trace, because this curve doesn't depend on z. You know it will be another ellipse, right, with the same ellipse, but that's when z is 3. So once you draw two traces, the trick is to draw lines through these two traces and parallel to z axis, because z is missing, right? So therefore you draw parallel lines, and like through here you draw parallel lines, and of course extend to the top and bottom, and then that's pretty much it. Of course it extends up and down. So this is, so draw another trace at that, and then the third step is to draw lines parallel to z-axis, because we know z is missing, through those two traces, right? So that's the trick to complete the graph. So this is called elliptic cylinder in this case, because. And let's take a look at the graph from the GeoGebra, and then you can see that this is a trace when z equals 3. It's also the same ellipse. Now let's look at how we graph this new one. Z equals natural log of z minus natural log of y equals 0, which is the same as z equals natural log of y. Here, first of all, you notice that x is missing. You do know that this cylinder, it is parallel to the x-axis, right? Second, I'm gonna, because it's parallel to x-axis, I want to look at its trace on the yz plane. So I'm gonna let x be 0, look at the yz trace. Okay, so which is z equals natural log of y. This is true for any x value. So you know what I'm gonna do. The next one is, say, draw another trace, right? So when x is -3, I don't have to use positive value. So another trace, and this will be the same, which is z equals natural log of y. So when I draw this graph, let's take a look at, this is x, this is y, this is z. So this is just a natural log function. So I'm gonna say this is x equals 0 and this is x equals -3. I'll just create two like hypothetical coordinates there, z and y, so that I can draw nicer. So natural log of z equals natural log of y looks like this, right? This is the graph of natural log. Okay, and similarly, on the yz plane, which is when x is equal to 0, you have this some kind of same graph. Now you connect these two using parallel lines that are parallel to x-axis, because the surface is supposed to be parallel to x-axis. So I'm going to connect these two lines. This is on the bottom. Okay, so therefore this is the cylinder that supposed to be drawn. So the third one is you're going to draw lines that are parallel to x-axis, right? So that's what it is. I would encourage you now to try something on yourself. For instance, give it a try on this one. Follow these suggested steps to see how you come up with. And of course, after that, draw this in GeoGebra, because that will be interactive. You can rotate it to look at the graph.